Hello friends and my dear students, I am Professor Anil Brahmin from Electrical Engineering Department, Sri Shankaracharya Technical Campus, and in today's lecture, as we have to explain, we have to go ahead and we have to concentrate on basic operation of address latch enable. This basic operation of ALE, as we have already explained, is to separate the address and data buses, particularly the lower order AD0 to AD7 buses. And by keeping in the background the earlier studied output, just we are taking a review of opcode phase cycle which we have already studied. The opcode phase cycle is actually basically having 4 T states: T1, T2, T3, T4, and during T1, as we have already explained, AL is enabled, and whenever it is enabled, the lower address PC low bit is placed on this demultiplex AD0 to AD7 buses, and this address is actually extracted by using ALE signal, and that is our main aim for today's study, but just we are taking a review. Now the higher order address bus A8 to A15 will be loaded by higher address. Say we have taken 20, lower address 01. Now whenever the memory is activated with the help of IOM bar signal, the IOM bar signal is activated low from the starting during this opcode fetch cycle, and whenever read bar is activated during T2 and T3, and with read bar and IOM bar, the memory read signal is generated during T2 and T3, and when this signal is generated, the opcode is from the memory is fetched or loaded into the data bus, and ultimately it goes to the instruction decoder as we have already studied. Now today we will go ahead by keeping this opcode phase cycle in the background. We will go ahead today and we will understand the utility of address latch enable and demultiplexing process. Thank you. Okay, as we have already explained the timing diagram for opcode fetch cycle last time, and today we have taken the review, and now today we will understand the demultiplexing operation of lower order address and data buses. These buses are AD0 to AD7, and as we have explained the different timing diagrams. Meanwhile, some students have asked me also that what is ALE. Today I will elaborate everything about address latch enable signal, and because this signal is very important in the microprocessor 8085, as it is separating out the common bus. The common bus is AD0 to AD7. These buses, if we are seeing the pin diagram, this AD0 to AD7 buses are from pin number 12 to 19, and at 20 we are having ground, and after that from 21 to 28 we are having, as you are seeing in the diagram also, we are having higher order address buses which are A8 to A15. So this ALE signal, today I will give you very important clue for remembering this ALE. very important say formula I will give you at the last. But first we'll understand how this ALE, address latch enable, is enabling the latch. Now the thing is, what is the latch and what is its importance in this demultiplexing process? Demultiplexing means it is separation of address and data buses. Now first we have to understand what the latch is and which latch is used for separating out the address from the AD0 to AD7 buses. So first we will understand the latch which is to be used here in the microprocessor for separating out the lower order address bus, which is basically a D latch. D latch, if you are remembering, the D latch is having input as D, say it is D, and depending on the enable signal. Enable is generally it is a clock. Clock is enabling the D flip flop, and depending on this it will generate output Q and Q bar. So out of this two outputs we may use any one. Now what is its property? That also we must know. The property of D latch is, if we are having, say if you see the truth table for this D latch, we are having say enable signal, then we are having the input signal of D latch, and then we are having output signals. These output signals are Q and Q bar. We are indicating it by plus, which means which is indicating the next state after the class, after the clock. Now what this truth table? First we will complete the truth table, and meanwhile when we are completing the truth table of D flip flop, we will explain it also. Suppose say in clock is not enabled, it is 0, and D input is also 0. What will be the output Q and Q bar? This Q and Q bar will not be activated, it will be as it is. Whatever the as it is means whatever the previous values are there, it will remain as it is. What does it mean? It means whenever clock is not activated, clock is 0. Whatever the previous data is there, this previous data is latched. Now the meaning is clear. Latching means holding a particular thing. That means this flip flop is whenever we are having, suppose clock is not activated, clock is 0. Whatever the signal here, suppose whether the signal is 0 or 1. If clock is equal to 0, this signal will be previous value. It does not depend on this. It will not change according to the input. So, if you see, if you complete the truth table, say if it is enable is 0, D is 0, as we have already explained, whether it is 0 or 1. If clock is 0, whatever the previous value of output is there, it will be holded, it will be latched, it will not change. So here again, if clock enable is 0, enable is means it is a clock. If it is 0, whatever the value of whether it is D is 0 or 1, this signal will be holded. It will be same. Whatever the previous value is there, previous value will be maintained. Now, when we are having, say clock is upright, suppose clock signal is 1, 0, 0 we have taken, 0, 1 we have taken, now we are taking 1, 0. And if D input is 0, clock is enabled. Here we are having some signal, clock signal, and if this is 0, the output will be, now it will change. It will be 0. Q will be 0 and Q bar will be 1. Similarly, if we are going ahead, if enable signal is 1, the D is 1, that means input is also 1, the output will be 1 and Q bar will be 0. That means signals will be transmitted. Here, whenever this is clock is enabled, whenever clock is applied to this flip-flop, it is transmitted. It is transferring. Transfer of input to output is there. And if it is not activated, enable is not activated, it will latch the value. Latch means it will hold the value. And as we have already explained, we want that lower order address must be holded. Must be holded by the flip-flop, so that here in the memory locations, a particular address will be pointed out. As last time we have taken example of address location 2001, and which we have already reviewed also at the starting. Which means this lower order address is 01. In 2001, lower address is 01, higher address is 20, which is loaded by the program counter. Now we have earlier we have seen at this location we have loaded a operation code 3E, which is the operation code of MVI-A. Its meaning is move immediately data to the accumulator, MVI-A. So we have already seen this. Now coming to the back to this, what is the lower order address? Lower order address is 01. This lower order address should be holded. That means this location should not change, because we have already seen in the timing diagram, during T1 the address is loaded on the lower order address buses, and during T2 and T3 the same buses has to carry the data. Which means if we are connecting directly without the latch, without this flip-flop, if we are connecting directly the lower order address buses to this address decoder, what happens? This will change depending on the data content. In our case, if this data will be loaded, this location will change. We actually want this location should be pointed. It should not change in between. While one machine cycle is to be completed, while one machine operation is going on, while we are reading from the memory and this data is to be sent to the microprocessor, this address must be holded. And now if you see the holding of 20, no problem, because this buses, higher order buses 20 is not multiplexed. So we have explained the D flip-flop. Now because this higher order address buses are not to be latched, so directly we can connect the higher order address buses. So higher order address buses, if we are seeing in the microprocessor 8085, we are having from pin number 21 to 28, we are having A to A15, and these buses are known as higher order address buses. Which means because these buses are to be directly connected with the microprocessor, so no problem in this. We may connect these buses directly to the address decoder, and as this we are completing the diagram, this can directly be connected with this higher order address buses of address decoder. So as we have connected here, these buses are higher higher order address buses, and these buses are ranging from, as we have taken, A15 and to A8. Total 8 buses are there, which can be directly connected with the address decoder, so that this 20 higher address can be decoded. And because this address is there in the address lines for all the T states, as we have seen for opcode fetch, which is of 4 T states or 4 up to all 4 T states, this 20 will be there, so no problem in that. Now we are coming back to our lower order address. We are having lower order address buses as from pin number 12 to 13, 14, 15, 16, 17, 18, 19. Total 8 buses are there, which are AD0 to AD7. Now these 8 buses are to be demultiplexed. Means the address of these buses must be extracted. Which means, suppose we are first understanding only one wire. Suppose this address is to be extracted, is to be holded. How it can be holded? Say we are connecting this to our D flip-flop, right? And now this D flip-flop output will be connected. This is AD7 and this output will be connected to the address decoder, where we are having all the address buses. Which buses? The lower order buses. Which means this may be connected directly to this, and now this side we may write it is A7. It is AD7 here and it is A7. Why we are writing like this? Because here we are having demultiplex buses. Data buses will also be connected. But here we are having only address buses. Address buses are to be connected to address decoder. Now how it will be, how it will separate, how it will extract this content and how it will latch. As we have seen, whenever clock is activated, whenever it is enabled, so what here at this point, at the clock of this flip-flop, what should be connected? This is the question. Certainly here we have to connect ALE, address latch enable. This is address latch. It is the latch, D flip-flop, which is used to latch the address. So here actually we have to connect the signal ALE, which is generated by the microprocessor, and it should be connected to the clock of D flip-flop. Now what is its meaning? As we have already seen, whenever this will be activated, then only transfer is there. And we have already studied this ALE is activated during T1 T state only, and after that it is not activated. If you see the timing diagram, it is activated at T1, and for other clock cycles it is not activated. So ALE is activated at T1 initially. That means when we are applying ALE to this, now this ALE signal will be clock for the D flip-flop. We should not apply this clock to ALE, to this D flip-flop. ALE is the signal and it will be applied to the clock signal of D flip-flop, so that whenever this is activated, the change will be there. Depending on the input, the data will change. Depending on the address, because address is loaded at the given time in the lower order address. Depending on the address, it will be loaded here. And after that, because clock is not activated, so this will be latched. This will be holded. So initially, say if you see this location, as we have already explained, say location number 2001, it means your lower order address is 01. That means the D0 will be 1 and all other buses, all this, or if this D0, if on this buses, if we are loading say 01, means this D0 will be equal to 0 and will be equal to 1 and others will be 0. All will be 0. This means, which means whenever it is 0, the 0 will be, same 0 will be transferred here and it will be latched for all these periods, so that this address location 2001 will always be pointed out. That's all. Now we will complete it. Similarly, the other lines are to be completed. Now, for seeing the complete diagram, as we have already explained, one flip-flop. Actually, we are using IC 74LS 373, which is what? Which is octal latch. Octal means 8. Octal latch means we are having 8 flip-flops in that. If we are having 8 flip-flops, 8 inputs are required, 8 outputs are there, means at least 8 pins for input, 8 pins for output, 16 pins, 1 pin is for ground, 1 pin is for plus 5 volt, 16 plus 2, 18, and 2 more pins are there in this IC, which are for, one is this enable, address latch enable, one is output enable, one more pin is there, output enable, which is activated low. So total, which is a 20 pin IC, and this is activated, output enable will be activated when it is grounded. So for enabling this IC, this output enable pin must be there, which is connected to each and every flip-flop. It is a 20 pin IC. The elements are D flip-flop. As we have already explained, octal means 8. If we are having 8 flip-flops, 8 input, 8 output, we are using Q, we are not using Q bar. 16, one is for ground, one is for plus 5 volt, 16 plus 2, 18, and 2 pins are there, one is for output enable, one is for say input enable, ALE. And ALE is actually controlling this address flow, and address is holded. Whenever clock is not activated, clock is what? Clock for this D flip-flop is actually ALE signal. Clock is not the real clock, is not used. If we are using that clock, it will change every time. If it will, this pointer will change, this address will change. Sometimes during T1 it will point out this, during T2 it will point out some other location, because these contents are changing. So this should not change. So in this way, now we can move ahead. Similarly, we may connect the other AD buses. Say it is the AD7. Now we are doing AD6. Similarly, we can connect AD5. We can connect AD4. So as far as connections are there, if you will have the understanding from basics, there is nothing difficult in that. In the electronics, generally we are seeing bundle of wires, but if we will understand the logic, things are very easy. Now see, in this way we can connect AD1 also, and we can connect AD0 also. These are the different inputs to this 74LS 373 latch: D7, D6, D5, D4, D3, D2, D1 and D0. Similarly, we are having outputs on this IC. These outputs are, say, O7, and we have again another O6. Again it should be connected to the address decoder. We are having O6. We'll have O5. It should be connected to again address decoder. We'll have O4. Again should be connected to address decoder. We'll have O3. Same manner it will be connected O3, which is equal to now say A3. Similarly, we will have O2, which is equal to A2, and as you are seeing, it should be connected to O1 also to be connected here. O0 to be connected here. In this way, all these address buses from A7 to, we can say, this is O0, which is equal to A0, this is A1. Now you can see we are having complete picture of address buses, which are this address are holded by the address latch enable signal. And now we will explain what happens during this T2 and T3 timing, because at that time data is to be loaded. Initially address is to be loaded on the AD buses, these buses. This address is now separated out during T1 time, and during T2 and T3 the data content is, say, 3E in our case. This 3E will be transferred in this direction through the same buses. Means this data bus connection must be here. Say, if you see this data bus connection, this should be, say, D7 must be connected to D7. Similarly, this D6 must be connected to the D6 data 6 line from the memory. Similarly, we can have other connections also. D5, AD5 must be connected with data 5 line. You can see in this way we can fully complete the connection diagram, and as I have already explained, it seems that too many wires are there, but if we are understanding a clear logic that how these connections are there, how this address will be holded, this is very simple, and this is very important question in CS2 examination also. It is generally 7 marks question is there in the examination, and in the competitive exams also the same. The multiple choice questions are also asked regarding different this IC 74LS 373, regarding this flip flop, regarding the pin, regarding the function of address latch enable, and in this way we are just completing the diagram. Just you can complete it because it should be completed, and in this way, if you are not seeing this portion. Now we are not be able to adjust the camera. You have understood the things. No problem in that. Just we are giving the connections. Because when I am taking lecture, sometimes you are writing, yes, right side is not visible. Because whenever the things are not of much importance, we are not because camera is away from me. We cannot adjust the camera, and nobody is there here to adjust the camera. So at the last, if some doubts are there or anything is there, we can clarify. No problem in that. But if some portion is not visible, say this lines, no problem. You have already understood this. Just I am drawing it. Say in this way, we can complete the total diagram of connection of each wire of data bus as well as each wire of address bus. Total, we are having 16 address buses. These are higher order address buses and these are lower order address buses. And these are the total connection diagram from microprocessor, latch and to the memory, which is divided into 3 portions: monitor program, user memory, stack memory. Generally we are writing program in the user memory. So in this way we can easily remember and we can understand the demultiplexing of address and data buses. And again I am giving you very important memory point. As I told you, I will give you very important memory point at the end of the lecture, and really you will enjoy it and you will not forget it. For that, say this ANE signal actually may be related with a very simple thing, that is Agra Lucknow Expressway. Now the thing is, what is the meaning of Agra Lucknow Expressway? It is related. Say time sharing of different things are to be done. Say before 5 years I have given suggestion to the रक्षा मंत्रालय. नाउ whenever जब हम एक्चुअली दिल की बात करते हैं तो हिंदी में करते हैं, तो दिल की बात दिल तक पहुंचती, सब चीजें याद रहती है. अब मैं आपको दिल की बात कह रहा हूं एंड विल रिमेम्बर इट. एक बार मैंने 2015 में एक सोच बनी, एक सजेशन भी लिखा मैंने रक्षा मंत्रालय कि भाई अगर हम रोड बना रहे हैं तो ऐसा स्ट्रॉन्ग रोड बनाएं और ऐसा जैसा एयरपोर्ट बनता है, और उस रोड को हम एयरपोर्ट जैसा भी यूज करें. इमरजेंसी में मान लो हमारे विमानों को लैंड करना है, हेलीकॉप्टर को उतारना है, आप पोल्स मत लगाइए साइड में, बाउंड्रीज मत बनाइए. एक पर्टिकुलर, जैसे मान लो रोड एक स्थान से दूसरे स्थान जा रहा है, रोड इट इज कनेक्टेड फ्रॉम वन प्लेस टू अदर प्लेस, तो बीच में मान लो एक बड़ा शहर आता है तो वहां एक ऐसा रोड बनाए जहां पर प्लेन भी लैंड हो सके, कोई दिक्कत नहीं है. और उसका हम टाइम फिक्स कर लें. टाइम ऐसे फिक्स करें कि भाई मान लो सवेरे 7 बजे से 8 बजे तक इस रोड पे सिर्फ हवाई यात्री उतरेंगे, प्लेन्स आएंगे जाएंगे, और उसके बाद ये बाकी ट्रैफिक के लिए खुलेगा. तो ऐसा हुआ भी है. मेरे सजेशन से हो सकता ना हुआ, है ना. मैंने सजेशन भेजा था, उसका कोई जवाब तो दिया है ना. बाद में एक लेटर आया कि इट हैज बीन इम्प्लीमेंटेड. कहाँ हुआ? हमारे देश में हुआ, और आगरा लखनऊ एक्सप्रेसवे में हुआ जब मुलायम सिंह और अखिलेश यादव की सरकार थी. तो मैं अब ज्यादा बताऊंगा नहीं, जस्ट यू हैव टू वॉच द फॉलोइंग वीडियो and things will be very clear to you. Watch this.
साइड हटोगे आप?
So don't forget the ALE, address latch enable, and you can remember the function of ALE by remembering the Agra Lucknow expressway. Okay, enjoy.